In this lecture, we are going to discuss about the Monte Carlo integration. So, our objective is to calculate this integration from a to b fx dx numerically or approximate value of this integration. This is our objective is to calculate. We know that first of all we have to understand what is the meaning of this integration. So as some of you might know that the integration is gives you the area under the curve. So for example, if this is your y-axis and this will be your x-axis, and if you have a curve which is defined over this two lines, that is x is equal to a and x is equal to b, then this integration is this area bounded by four curves. The first one is a line x is equal to a, the another one is x is equal to b, then this y equal to 0 line, that is x-axis, and the curve y equal to f of x. So this area is represented by this integration. So probably some of you is known about this fact. Now how we can calculate or we calculate this integration numerically? That means what will be the approximate answer to this integration? Because why it is needed? Because every time it's not necessary that we can able to solve such integration. So in that case, we'll need to understand what is the numerical solution for that. For example, if I have given you this integration 0 to 1 e power minus x square dx, then it is difficult to integrate, or rather it is impossible to integrate this integral. So the question is, what will be the area under that curve? Area under the curve e power x square. Actually, this factor is coming into the normal distribution function. So to do this, we have to integrate this, or numerically we need to find the answer for that. So for that, there is one technique. It is in the Monte Carlo method. In that technique is to evaluate this integration. So let us see what is this technique is. So probably you know that the expected value of the function of the random variable f of x can be defined as e of f of x is equal to integration f of x into px x, where px is the probability distribution function of the random variable x. And you probably have learned about this one in your statistics, so I'm not going to go into the detail of that. And the variance of the random variable x can be expressed into the two formulas, which is the expectation of x minus expectation of x whole square. So the expectation of this one is known as the variance, or another formula is expectation of x square minus expectation of x whole square. So here our objective is to calculate that integration from a to b, f of x dx. So for that, what I will do, will pick up one random point into this interval a to b. So this is your a and this is the b. Now we'll pick up one random point in between this a to b. Let's say that point is x. So we can able to draw. So we'll have the f of x, which is here. This is the straight line. The green line I have plotted this straight because, okay, let me draw a straight line into that. Otherwise, it may create confusion. So this is the f of x, this point, which is on this curve y equal to f of x. So this is my point f of x is there. And then we can draw this rectangle. That is this rectangle from here. This is the point B. The point B is drawn separately, but it is not there. It is this blue line and the green line is the same. So this is the point B. So this area of this rectangle, what will be the area of this rectangle? That is the height into its breadth. The breadth will be b minus a. That means this distance from here to here. And the height we have, it is f of x. So the area of this rectangle we can calculate as fx into b minus a. That we can have as the area of this rectangle. And in the similar manner, what we can do is we can pick out some random points into this interval a to b. And in the same manner, we can have some area of this rectangles. So for example, if I have a curve, the same curve will use, that is the same curve we have. So in that first time, let's say the point we have taken is this, and according to that, the point, or you can have the value is this one. So you can pick out this rectangle. So you just find out what is the area of this rectangle. That is the point that is we have here, which is f of x, or I can say x1. This point is x1. So area of this rectangle, which we have here, is f of x1 into b minus a. That is the area. And the second times, maybe we have taken another point. Let's say the point is here, and so we can have the some rectangle here in this case. Okay, and in that case, let's say this is x2 point, and so we have the point x2 into b minus a, and so on. Let's say in the same manner we have four such area, and we can able to find out all these values. So we can have the mean of that areas, and that is approximating this area which we have, the area which we have as a function of that area. That means this area is approximated by average of all such areas of rectangles. So in the first time we have this rectangle, in the second time maybe we have some higher rectangle according to the function, and so on. So we'll have such areas, and average of those area will gives you the approximate answer for that integral. That means if I want to find out that area, then by mathematically we know that it is the summation I running from 1 to n minus 1, 0 to n minus 1. I'm just taking the 0 point and I'm taking the point that is f of xi into b minus a, b minus, so it is the average, sorry, it will be the area of the each rectangle that I have talked here. That means first rectangle is x1 into b minus a, second is f of x2 into b minus a, and so on. So we have taken in such manner there are n rectangles, and the average value of that value, so the average of this values, which is 1 by n, is the expected, or I can say it is the approximate answer to this integral. So that is where n is the number of samples. What is n is the number of sample is used to approximate this integration. And this is known as this basic estimator, where the value of xi, what is the value of xi, you can say this xi, these are the points which are the points in between a and b. So I can say that it is a plus xi plus b minus a, where what is xi? Xi is the uniformly distributed random numbers between 0 and 1. So the xi is any random numbers between 0 and 1. So if you put that value of xi here, then it will convert your xi in between ab. And using that you can calculate your function, and this will gives you that estimated value, and we can denote it, this is by some f n, and one can discuss the probability of this one. The probability of this is 1, and one can also discuss its x. What is the expectation of this function? The expectation of this function has to be the integration from a to b. Let us try to prove that. So that is expectation of this quantity, but this b minus a is independent of I, so I can write down this is 1 upon n into b minus a into summation I running from 0 to n minus 1 f of xi. Now if I take this expectation inside the summation, so this is 1 upon n b minus a summation I running from 0 to n minus 1 expectation of f of xi. So that is nothing but the expectation of f of x, that is 1 upon n b minus a into expectation of x, but expectation of x, f of x is the distribution, probability distribution is there. So that's why it is 1 by n b minus a summation I running from 0 to n minus 1 integration from a to b. The expectation of f of x is f of x into PDF of f of x dx. That means whatever the probability distribution function is there. But probability distribution function is 1 for this. That's why it is integration from a to b. So this will gives you expectation of Fn is 1 over n b minus a summation ironing from 0 to n minus 1 integration from a to b fx dx. Now this one is independent of x and this summation is coming n times. That's b minus a is also okay. B minus a is cancelled with this PDF of f of x. So that's why this b minus a is not come here. And this summation is coming n times. So this n is also coming cancel out. And so we'll have this integration from a to b fx dx is left. So PDF is equal to here 1 upon b minus a. That we need to remember. For here we have PDF of x is 1 upon b minus a. That cancel with this. So and the summation is coming n times because it starts with 0 and with n minus 1 and this is independent of I. So that's coming out. So it is 1 plus 1 plus 1 n times. So that's why it is n and that n is cancelled with this n. So that's why this estimation or estimated value of this will be this much. So into the generalized form of this integration, one can say that this function fn is 1 upon n summation I running from 0 to n minus 1 f of xi upon PDF of f of xi. If we generalize this, we can write down into this form. This is more generalized form of this is known as a Monte Carlo estimator. This is known as a Monte Carlo estimator, and we have to remember this formula every time when we integrate this. We'll use this one. Okay, that we can use that, and now let us see how we can solve one of the example. So let us take this example. Let us consider this integration of 0 to 1 4 into square root of 1 minus u square du. So the question is to calculate the value of this, and we have to calculate this is numerically, but for now let us, so anyone know what is the integration of this quantity, how to integrate this? So probably you know that there is a function or there is an integration of the form a square minus x square dx. What is the integration of a square minus x square dx? If anyone know how to integrate this? So I think so you studied this one in your 12th standard. Those were science subject. So I'm not going to discuss that one here. So that you can verify this is equal to this value is equal to pi. This you can verify by yourself. Okay. So is another way is to estimate pi, value of pi. So as per this integration which we have discussed here, it says that 1 upon n into the f of xi upon PDF of that one. So what we are doing is we are just calculating some random points between, in according to this, it is between 0 and 1. If the interval is not 0 and 1, then we can generate a point in that interval, whatever the interval is given to us. So if you want to make the estimation of this integration using this, so I am making a function which is pi mc. Why I am saying it is pi mc? Because it's estimate the value of pi is equal to function, a function of n, that is the number of points which we have here, which is summation is running from how many points are required in that. Then I'm generating this u. U is a random variable, that is according to the previous one, that is xi that we have saved. So that xi I am just using the function r uniform, which is inbuilt function is there of n. Then creating this function f, which is 4 times square root of, so the function is xqrt, square root of 1 minus u square. So it will calculate all these values. And then what it says, it is the mean of that. PDF is 1 minus 0 for this case, because you can see that it is the general form, but we go previously, we have this as the formula. That is b is 1 here, a is 0. So that's why it is b minus 0. So that is nothing is to multiply here. So 4 into this function, that is f. And then we can create this pi mc, which is the output of this, which is the mean of this function f, whatever the mean is there. Because ultimately we have seen the mean of that value. So whatever the value, this is the value we have calculated, f of xi into b minus a, and then divided by n. So that's why we are taking a mean of that into the function. And then we print that pi mc, and the function is over. If you run this one, then it will estimate the value of pi, and which will also include, or which we can be also calculate the value of this integration. So let us do it in the R. So for now, I'm stopping this sharing for this and starting my